please mute yourself. So hello everyone, my name is Abhishek Pandey. I'm a Prime Minister Research Fellow in the discipline of Mathematics at IIT Bhubaneswar. Today we are going to discuss about week 3 assignment. So let us start the discussion. So as you can see the first question. So first question regarding the power series expansion of the polynomial. Okay. So let fz be a polynomial in the complex variable z of degree n greater than equals to 0, an non-zero. Which of the following are true? So we have to check the validity of these statements, okay, whether it is true or not. Okay. So let fz is this. So it is a polynomial, okay. So we can compare it as a power series, okay. What we do, we will write aj equals to 0 for all j greater than equals to n plus 1. Okay, so it will become a power series, okay. And the radius of convergence, I will shortly, in short, I will denote it as ROC. So radius of convergence is 1 upon limit supremum of mod an to the power 1 by n, okay. So this will be infinity because this will be 0, okay. Is it clear? So since the radius of convergence is infinity, thus f is an entire function, okay, and hence it has a power series expansion around every point w belongs to C, okay. So the first option is correct. F has a power series expansion around every point C. The radius of convergence of the power series of f around any point w belongs to C is infinity. Since f is entire function, so this option is also true. Let us look at the third option. Third option is saying there are only finitely many points w belongs to C such that a naught equals to 0 in the power series expansion of f around w naught. Okay, so let us look at it. Let us look at the option C. So power series expansion around w naught. So fz can be written as bn z minus w naught to the power n. Okay, n equals to 0 to infinity. Okay, obviously bn will be 0 from n plus 1. Okay, so now it is asking there are only finitely many w's such that a naught equals to 0. So basically a naught, so basically this is bn, so basically a naught in every case, what would be a naught? So here what is a naught? In this case what is a naught? A naught is nothing but f of 0, okay. So in other cases what will be the constant term? F of w naught. So basically a naught is nothing but f of w naught, okay, and it is saying a naught equals to 0 means f of w naught equals to 0. So w naught is a root of p of f. So let me write it precisely, of a polynomial. Polynomial, and a polynomial can have only finitely many roots, okay. So this is saying there are only finitely many points, okay. There are only finitely many points w belongs to C such that a naught equals to 0 in the power series expansion of f around w naught. So this option is also true. There will be only finitely many points, okay. Now since f is a polynomial, now let us look at the fourth option. There are only finitely many points w belongs to C such that n plus 2 is non-zero in the power series expansion of f around w, okay. Since f is a polynomial of degree n, so when you, so let me write it as C, so let me write it as D, okay. So since f is a polynomial of degree n, so Therefore, f will always be a polynomial when we write power series expansion around any point W belongs to C. Okay. So F will remain. So this will. So F always remain a polynomial of degree n. Okay. So since whatever the expansion will be around W, F is again a polynomial of degree n. So its an plus 2 coefficient is obviously 0. So for any W, if you write a power series expansion of F around W, its an plus 2 will be 0. Okay. So it is saying there are only finitely many points W belongs to S such that an plus 2 is non-zero. Okay. So what would be the answer? Hello. We are getting an plus 2 equals to 0 for every point W. Okay. Hello. Is it clear to everyone? Anyone can respond? Someone can respond. Hello. Hello. Pooja Dhokya. Okay, fine. Okay. So an plus 2 equals to 0 for every point W belongs to C. So an plus 2 is non-zero. What we are getting? We are getting only, so this set will be 5. Okay. Is it clear? So the collection of all W where an plus 2 is 0 is basically a 5 set, null set. Isn't it? Hello. 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 Am I audible? Now it is fine. Hello. Now is it fine? Wait, let me check. Wait. So now it is fine. Now is it fine?
Yes.
Okay, fine. Okay, fine. So let us look at the next option. Suppose f has all its root in C and does not have any repeated roots. Then the number of points W belongs to C such that the constant term of the power series on W equals to 0 is n. Okay. So this is also based on the root of the polynomial. Okay. So suppose f has all its roots in C and does not have any repeated roots. So means all the roots are distinct. Okay. So it has n roots, say alpha 1, alpha 2, alpha n. And remember that all are distinct. So consider the set S. W belongs to C. So S is a collection of all complex numbers such that constant term of the power series around W equals to 0. Okay. So what does it mean? So what will be the constant term of a power series around some point? It will be the value of the power series at that point, isn't it? So, hello. So like, so like if you have a power series expansion, suppose fz is equals to summation a n z minus z naught to the power n equals to 0 to infinity. So what is the constant term? So constant term is nothing but f of z naught, isn't it? Okay. So basically S is a set of zeros of f, and thus cardinality of S is n. Okay. So this is true. Now let us look at the last option. Okay. So let us look at the last option. So it is given that fz is equals to 125 z per cube plus 64 minus 1500 I z per square, and this and this. So constant term in the power series expansion of f about the point 4i is f of 4i, and at the calculation you can check. So it is just on the calculation part. You can check f of 4i is non-zero basically. You can check this one. So this is just based on the calculation. So this is also wrong. Okay, let us look at the second question. Okay, so now suppose f is a power series around 0 given by this, okay, with a positive radius of convergence. So ROC of f, so I will, in short I will write ROC for radius of convergence. So ROC of f is positive, okay. So we need to check which of the following statement is true, is or true. So let us look at the first option. If ai equals to aj for all ij, okay, so means a naught is equals to, so basically all the coefficients are constant only. An is basically constant, okay. So you can take a naught or whatever it is you can take. So I will take a naught. So basically f of 0 is nothing but a naught, okay. Then f is uniquely determined by f of 0. So it is nothing but f of a naught only, okay. So f can be uniquely determined by a naught only, okay. What is a naught? A naught is f of 0, okay. So this is true. Now the second option is, if ai equals to aj for any two I comma j belongs to this one and a naught is non-zero, okay. So basically an equals to a naught for all n greater than equals to 0, okay. So f of z is equals to this, and what will be the radius of convergence r? So ROC will be 1 upon limit supremum of mod an to the power 1 upon n, and this will be nothing but 1 only, okay, because an is constant, so this will be 1. So r is 1, so radius of convergence is 1, okay. So this is also true. Fine. Is it fine to everyone? Okay, fine. So now let us look at the third option. Third option is also easy. So let an is equals to n plus 1 into an plus 1, okay. So this will be the coefficients, sorry, so this will be the terms, okay. So now you write fz is equals to a naught plus summation a n z to the power n from n equals to 1 to infinity. What will be its derivative? Its derivative will be n a n z to the power n minus 1, okay. Okay. So this can be written as, hello, hello? Yeah. So the derivative will be this. Now this can be written as, you can so here the starting term is 1. If you want to start it from 0, this will become as n plus 1 a n plus 1 z to the power n. You just need to put n plus 1, okay. So this will start from 0. So if you put 0, you will get first term. You will put 1, you will get second term, okay. And this is nothing but a n z to the power n. Why? Because n plus 1 an plus 1 is nothing but an, okay, and this is nothing but fz, okay. So f dash is nothing but f itself in the radius of convergence. So this is also true. Now define gz. So the option third is define gz like this, okay. So it is a naught square plus, so we are just squaring the coefficients of the power series, okay. So we need to check the radius of convergence of this g. In general we will check. So let gz is equals to a naught square plus summation an square z to the power n, okay. So now you compare it with summation n equals to 0 to infinity b and z to the power n, okay, and let the radius of convergence of f is r, okay. So what will be the radius of convergence of g? 1 upon limit supremum of mod bn to the power 1 by n. What is bn? It is nothing but an square, okay. So this you can write it as this, and this you can write it as this, okay. So this term is nothing but r, so it will be r square, okay. So means ROC of G is nothing but r square. So it is asking if radius of convergence of f is 2. So if r is 2, what will be the ROC of G? It will be 4, okay. Clear? So this option is also wrong. Now let us look at the second question. If f has a radius of convergence equals to 1, then the positive expansion of f around the point 1 by 2 also has a radius of convergence equals to 1. So this option is also not true. We will see it. Okay. So for counter example, you take fz is equals to summation z to the power n. Okay. So this is nothing but 1 upon 1 minus z, isn't it? Everyone is with me? Hello? Everyone is with me? Okay. So now you can see that the ROC of this f is 1. Okay. Now if you expand this function around 1 by 2, so like pictorially you can see that. So if you want to expand it around 1 by 2, so the largest ball you can contain in this one will be this radius ball only. Okay. So the radius of convergence will always be less than 1, obviously. Indeed. Okay. So indeed the radius of convergence of this f around 1 by 2, the positive expansion around 1 by 2 is less than 1. It is not equals to 1. Okay. So this is option is also false. Okay. Is it clear to everyone? Hello? Okay. Okay, Anupam. Okay. So let us look at the third question. Let fz is equals to 2 plus summation n equals to 1 to infinity 3z minus 7 upon n to the power n. Okay. This is the f, and the ROC of f around the point 7 by 3 is r. So what would be 3r? Okay. This is the question. So we need to find the radius of convergence of this power series. Okay. So you just take 3 common, so it will come as a standard form. Okay, this form. This is a standard form of power series. So an will be 3 to the power n upon n. So you will take this limit. You have to calculate this limit. If this limit exists, it will be the radius of convergence of the power series. Okay, if this limit exists. So let us check whether this limit exists or not. So this is a simple limit. So this will exist. It is 1 by 3. So radius of convergence is 1 by 3. So what would be 3r? It will be equals to 1. Okay. So the answer is 1. Fine, everyone. Okay. Fine. Now let us look at the fourth question. So this fourth question is a little bit tricky, but I will try to make it as simple as possible. So let P be a polynomial with positive coefficients, okay. Then ROC of the following power series. So we have to find the radius of convergence of this power series. Now if you look at this power series, this is not in the standard form, okay. So this is z to the power n factorial, okay. So we cannot directly write the coefficient, okay. and this polynomial is nothing but this polynomial is there and all this coefficient is positive plus they belongs to z. Okay, so it is basically so basically ak belongs to what? Natural number, isn't it? Positive integers, natural number. Okay, so consider this one, compare it with bn equals to compare it with this standard power series form around 0. Okay, so b not equals to 0 and bn will be pn upon n factorial if n is equals to m factorial for some m and 0 otherwise. Up to this it is clear to everyone? Let me know. Up to this is it clear? Okay, fine. So now what we will do, we will take a particular example. Okay. Okay. So now what we will do, so you can just take pz is equals to constant, any constant polynomial you can take. So suppose pz is equals to 1 here. Okay. So to find the limit radius of convergence r, we need to find the limit supremum of mod bn to the power 1 by n. Okay, so once the polynomial is 1, okay, so what will be p of n? This is also equals to 1 for every n. Okay, so basically we need to find the superior of limit supremum of 1 upon n factorial to the power 1 by n. Okay, and this will be equals to 1, isn't it? Everyone with me?
Yes, sir.
Okay. So this question is for any polynomial with positive coefficient. Okay, and we have to find the ROC of power series. Okay, so for a particular polynomial we have found that ROC is 1. So for every polynomial p, the radius of convergence will always be 1 only, isn't it? So this is just a technique to solve these kind of problems. Is it fine to everyone?
Yes, sir.
Okay. So let us move towards the question number 5. Okay, so this we will prove it using cos. Sorry.
If you take a non-cost polynomial, then
Yeah, then also this limit superior will be 1, but for that you need the calculation to find this one. Okay, so for these kind of problems, so suppose this problem is asking for let p be any polynomial. Okay, so if you change the polynomial, radius of convergence should not change, isn't it? Radius of convergence will be same always. That's why it is asking in the question format.
okay.
You got it? Yeah.
Yes, I.
Yeah, so you can, to solve this kind of problem, you can take a simple polynomial and check. So for any so for a particular polynomial, whatever with the ROC, it will work for all the polynomial. Okay. So to just make it easy, I choose the constant polynomial. Okay. Otherwise, you have to do the log calculations for a general polynomial. Okay. So let us look at the question number 5. So before solving question number 5, I will write a theorem and its proof. So let f, so here omega is domain. So domain means open and connected. It's connected. Okay. So let f such that omega to c is a holomorphic map. Okay. If f of omega means image of omega is contained in the line, a straight line. Okay, where L is a straight line, then f is constant. Okay. So let the equation of a line L is y equals to mx plus c. So in general, okay. So m is basically a tan theta, okay. So that is the argument of that line, means angle from the positive real axis. And f of x plus iy is u of x comma y and I v of x comma y. Since f of omega is contained in L, so this should satisfy the equation of line, okay. means this should satisfy, so v of xy should be of this form. So v of xy should be m of u x comma y plus c. Is it fine to everyone? Hello? Okay. Okay. Now, after this is just a mere calculation. Okay. So, u of x comma y plus I, v of x comma y I have written like this. Okay, fine. So, we get, now you calculate vx and vy. So, since v of xy is this, so vx is equals to mux and vy equals to muy. Okay, fine. But since f is holomorphic in omega, so it satisfies CR equation at each point in omega. Okay, so it will be ux. So this is the Cauchy-Riemann equation: ux equals to vy and uy equals to minus vx. Okay. And so now you put the values. Okay, so vy is nothing but muy. So ux is equals to muy and uy equals to minus mux. Okay. Now ux will be, now according to Cauchy-Riemann equation, what will be uy? Hello. Hello. Is it fine up to this?
Yes, sir, fine.
Okay. Okay. So what you will do, so uy equals to minus mux. Okay. So ux is equals to minus m square ux. So 1 plus m square ux equals to 0. Since m square plus 1 cannot be 0, therefore ux is equals to 0. And since ux is equals to 0, you will get all the partial derivatives of 0. And as we know, if f is differentiable, the derivative of f is nothing but this, ux plus ivx. So it is 0. So derivative of a holomorphic function in a domain is 0, means that function is constant. Okay. So what we have proved? So we have proved that if image of a holomorphic function lies in a line or on a straight line, then that holomorphic function is nothing but a constant function. Okay. So according to that, this one is false. Okay. So you can check. So you can take any constant function, not only 0. Okay. So this is false. Suppose that f is holomorphic function defined on a domain omega such that the image of f is contained in a straight line C, then f is constant. So this we have proved. So this is true. Now let us look at the third option. Okay. So let f such that omega to C is holomorphic such that mod of fz is equals to k for all z belongs to omega. So what is the third option? Let us look at again. So third option is if f is an holomorphic function in a domain such that mod of f is constant, then f is also constant. So we have to check the validity of this statement. Okay. So let us mod of f of z is equals to k. So if k is equals to 0, we are done. If k is equals to 0, modulus is 0, then f is 0. So it is holomorphic. So there is no problem. Okay. Now if k is non-zero, if k is non-zero means f of z is non-zero for all z belongs to omega. Is it fine? This observation is fine to everyone?
Yes, sir, fine.
Okay. So now you just square it both sides. So this will be mod fz square is equals to k square. This can be written as fz into fz bar is equals to k square. So what will be fz whole bar? It will be k square upon fz. Okay. So this will also be holomorphic. Is it clear to everyone? So f bar is also holomorphic. So in the earlier class we have seen that f is holomorphic and f bar is also holomorphic if and only if f is constant. Okay. So f is constant. So this option is also true. Now let us look at the fourth option. So fourth option is f of z is equals to xy. This is just a, easy task to do it. So you need to just calculate the partial derivative. So ux is equals to y, bx is equals to 0, uy equals to x, vy equals to 0. So at origin means at x comma y equals to 0 comma 0, f satisfies the CR equation. So this is true. And this satisfies the CR equation only at 0, not other than that point, okay? So basically it is not differentiable on the unit disk, okay? So holomorphic, so it obviously cannot be holomorphic, okay? So this is also wrong. Is it okay to everyone?
Sir.
Okay, now let us look at the sixth question. Yeah, so for sixth question also I will first write a theorem and prove it. So f is entire if and only if conjugate of f of z, conjugate of z, okay? So f of z bar to the power whole bar is entire, okay? So this is, so let us prove it, okay? So let f is an entire function, then f can be written as a power series expansion around every point z belongs to C. So in particular, I will take that point as z equals to 0, okay? So fz is equals to this. Now fz bar is this. Fz bar to the power whole bar is this, okay? So this will be nothing but this one, a n bar z to the power n, okay? And from this one you can see that mod c n z to the power n is nothing but this, this and this one, okay? So it will be, so mod c n z to the power n is nothing but mod c n bar z to the power n, okay? Fine. So thus c n z to the power n converges absolutely if and only if c n bar z to the power n is absolutely convergent in the region. So this gives the if and only if condition of analyticity of f and f bar. Means, sorry, f and f z bar to the power whole bar, okay? So is it clear to everyone? So if c n z to the power n converges absolutely in some region, c n bar z to the power n will also converge in that region. Because once you calculate the radius of convergence, you will go through the cn bar upon cn plus 1 bar, okay? So this will be nothing but cn upon cn plus 1, okay? So this is again will be the radius of convergence of the f, okay? Is it clear to everyone? Hello?
Yes, sir. Yes, sir.
Okay. So now first option is true since e to the power z is entire. So therefore e to the power z bar to the power whole bar is also entire. Yeah, first option is true and this option is also true, fifth option. Okay. Now let us look at the second, third and fourth option. So second option is just a mere calculation. So once you, so this you have to calculate. So the second option says if this is equals to this, if and only if this sin z bar is equals to 0, okay? So by the calculation you can see, so sin z bar you can write it as sin x minus iy to the power whole bar. So this you can write as an expansion of sin x minus iy, okay? And once you put the bar on it, it will change the sign this one from this to this, okay? So this will be nothing but sin x plus iy, okay? So this is nothing but sin z. Now this is, now the question is saying this is equals to minus sin z, and we have calculated that this is equals to sin z, okay? Thus we have sin z is equals to minus of sin z. So this will imply sin z is equals to 0, okay? So this will give if and only if sin z bar is also 0, okay? So this option is true. Now let's just look at this one. We have cos z is equals to 0 if and only if cos z bar is equals to 0. Let us look at this one. So let cos z equals to 0. So means cos x plus iy equals to 0. Now you write the expansion of this one is equals to 0. So the whole, if this is 0, its conjugate is 0. So its conjugate is nothing but cos z bar, okay? And this is 0. So this is if and only if. So this is just easy calculations. These are just easy calculations. So this is also true. Now let us look at the last fourth option. So okay, so no, so this will be, I think, I think it will be D, option D it is. Okay. So option D is asking for if P such that C to C is a non-constant polynomial with coefficient in C, then this holds. What is this? So P of e to the power z bar to the power whole bar is equals to P of e to the power z. Okay. This we need to check. So let us look at this one. So what I will do, I will take a particular polynomial z plus I. Okay. So just a translation. Okay. So P of e to the power z will be e to the power z plus I. Is it clear?
Yes.
Okay. So now once you calculate this one, you will get nothing but e to the power z minus I, and which is not equals to e to the power z plus I, obviously. Okay. So thus this option is also not true. Okay. So this option is not true. Okay. So we are done with the today's assignment. Any question, anyone? Feel free to ask. Anyone has any question? Hello? Just you can write in the comment box if there is no question. So I will just close the meeting. So everything is clear to everyone? Like all the assignment question is clear to everyone?
Yes, sir. Clear.
Okay. Okay, fine. Okay, so if there is no questions, so should I close the meeting? Let me see the chat box. Okay, fine. So we will meet on next week. Okay, at the same time, Friday 7 to 8 p.m. Okay. Okay, so I will just close the meeting. Okay. Yeah.
Thank you,
So
sir.
yeah. Thank you, Sarvana. Thank you. Okay, wait. One question is there. Let me handle this question. Okay. So at the boundary points of the disk, power series convergent or not? Okay. So yeah, this is a very good question. So let me take a look on this one. Okay. Okay. So like I will write a theorem. From that it will be clear to everyone. Okay. So the theorem is like this. Okay. So if you have a power series, so if you have a power series summation n equals to 0 to infinity a n z minus a to the power n, okay, and define a number r is greater than equals to 0 and less than equals to infinity by 1 by r equals to limit superior of mod a n to the power 1 by n, okay, then then if mod z minus a is less than r, okay, this series converges absolutely. Okay, if mod of z minus a is greater than r, this series diverges. Okay, and also for r greater than 0 and less than r, okay, series converges uniformly on z such that mod z is less than equals to r. So once you take, okay, so once you take the boundary points, like the boundary of this circle of convergence, so once you take the circle of convergence, on that we are not sure, okay? We cannot say anything whether at every point the power series will converge or not, whether some point power series will converge. So there are a lot of examples around this. So you can basically construct a dense subset of a circle of convergence where power series is convergent, okay? You can construct such kind of thing. And you, hello? So Thangeswaran, is it clear to you?
Sir, clear, sir.
Okay. So this is the theorem. On the circle of convergence, we cannot say anything in general. Okay?
Okay.
Yeah, so fine. Any other question?
Sir, can you say about continuity of sin z by z?
Continuity of sin z by z. So what is your function? You are defining fz is equals to sin z by z when z is non-zero, obviously. And at 0, what you are defining? Hello?
And 1, sir, there is 1 at z equal to 0.
Yeah, so it is continuous. You can check the limit sin 0 upon 0, like the usual limit you can check now. Or you can write the expansion of sin z and then you can divide it by z. Is it clear to you?
Yes, sir.
Okay, fine. Any other question? Like you can write the expansion of sin z and divide it by z. So you will get the, at 0 you will get 1. So that is the value. Okay, any other question? Okay, thank you, Sir. Anyone, any other question?